Hello, this is Mrs. Salisbury. This lesson is to help you gain a better understanding of the unit circle and how to find sine and cosine values of various degree and radian measurements on the unit circle. So before you watch this video, you should have a couple skills under your belt. You should know your special right triangles. You should be pretty comfortable with radian to degree measurement, and you should be comfortable with reference angles. If you need some more practice with reference angles, I did make a video, so you can check the playlist and find the video on reference angles. So once you have those skills down, watch this video, and I'll show you another way to kind of think about the unit circle. So what we're doing on the unit circle is we're just putting a bunch of different examples that I'm about to show you together on one circle. And for a lot of people, it helps them to see everything together because then they get the big picture. But for some students, I have found that it's actually a little overwhelming. So what I'm going to do in this video is break it down into piece by piece, and then hopefully you can look back on your unit circle and see how it all ties together. So let's take a look at one example. So let's say on the test, I give you something like sine of 135 degrees. And you're going to need to simplify this without a calculator. So you should probably be able to do this in about 20 to 30 seconds or less. So you could theoretically memorize the entire unit circle, but that's really hard. There's a lot of values on there. And I don't know about you, but I cannot memorize that much. So I have to think it through. So the first thing I think in my head is I picture the angle on the circle. So here's 135 degrees is somewhere right here. So if you look above at the unit circle I drew, we've got 90 degrees as the positive y value, 180 as the negative x value. So 135 is about halfway in between. It's exactly halfway in between 90 and 180. So after I draw the angle, I want to find my reference angle. And if you notice, my reference angle is 45 degrees, which is great because that means I can now pull in my 45, 45, 90 triangle. So I'm looking for the sine of 135. So we have our 45, 45, 90 degree triangle here. And I know that my sides are root 2 over 2 and root 2 over 2. So it's asking me for the sine of 135. And I know that sine is opposite over hypotenuse. And I know that on my unit circle, my hypotenuse is always 1. So for my sine of 135, it's the same as my value here for 45 degrees since it's the reference angle of 45 degrees. So I know that my sine of 135 is going to equal root 2 over 2. Now the only other thing I have to think about is it positive or negative? So that's where you have to remember that we are on the coordinate plane. We've got our x and our y axes. And I know that to get to quadrant 2, I need to go left and up. So that means my x value would be negative, but my y value, sine, would be positive. So if I had asked you for cosine of 135, that would equal negative root 2 over 2, because cosine is my adjacent, which is my x value right here. Let's look at another example. Let's say I said cosine of 300 degrees. So same thing, step 1, I want to think about where my angle is, which is somewhere right here. So if this is 360 degrees, I know that this has to be a 60 degree angle right here. So 60 degree reference angle. So do that a little better there. So 60 degrees reference angle. So that means my side lengths are root 3 over 2 here and 1/2 here. And now since I'm in the coordinate plane, think about how I get to this point. I go to the right 1/2, so that 1/2 is positive, but then I go down root 3 over 2, which is negative. So cosine of 300, that's my adjacent, over hypotenuse, which is just 1. So it's just positive 1/2. And if I had asked you for sine of 300, that would be my negative root 3 over 2, because sine is opposite over hypotenuse. So each time, sketch the angle, find the reference angle. It's going to be 60, 30, or 45. Or if we're working radians, it's going to be pi over 3, pi over 6, or pi over 4. And then all you have to do is draw your special right triangle and figure out whether it's positive or negative depending on what quadrant we're in. Let's do a couple more. So try this one along with me. So first start by sketching out the angle. And remember, it's a video, so you can pause it while you sketch it out. I'm going to kind of just keep going along. So try sketching out sine of 120. Or really just 120 degrees. So we know 120 degrees somewhere right here. So how much more to get to 180? So we know this angle right here is 60 degrees. So again, we've got our 30, 60, 90 triangle. We know that our side lengths are root 3 over 2 and 1/2 here. So sine is opposite over hypotenuse. So just root 3 over 2. And since it's quadrant 2, I know to get to my point right here, I need to go left and up. So my y value is positive. My x value would be negative. So if I asked you for cosine of 120, that would equal this negative 1/2. So you can quiz yourself like this. You can make flashcards, you can just look at your unit circle and cover up the sine and cosine values, but quiz yourself on these different degrees. And let's do a couple radian examples. Let's try sine of 5 pi over 4. So first sketch out the angle. So I know that my reference angle is pi over 4. So I've got my 45, 45, 90 triangle. And I know that my side lengths are root 2 over 2. So if I'm looking for sine, that's my opposite over hypotenuse. So that's going to be root 2 over 2, but since I'm going down, it needs to be negative. So my y values in quadrant 3 are negative. If I had asked you for cosine of 5 pi over 4, that would equal negative root 2 over 2 as well, because here I'm talking about my adjacent over hypotenuse. Let's try another one with radians. Let's try cosine of pi over 3. Well, I don't even need the unit circle for this because I know that cosine of pi over 3, here's my pi over 3 on my 30, 60, 90 triangle. I'm looking for adjacent over hypotenuse, so that's just going to be 1/2. And I know it's in quadrant 1, and both my sine and cosine, my x, my y values, were positive in quadrant 1. Let's do one more in radians. Let's try sine of 11 pi over 6. So I know that is right here. So my reference angle is pi over 6. So I know that I've got 1/2 here, and I've got 1 here, and I've got root 3 over 2 here. So sine is my y value, which in quadrant 4 is negative, so this equals negative 1/2. And my cosine, if I'd asked you for the cosine, my x value is positive here, so that's just going to be root 3 over 2. So what happens when I have something like 90 degrees, where I don't really draw a triangle? So here, we just really want to think about this unit circle here. So remember that the unit circle means that I've got a radius of 1. So if I've got something like, let's say 0 degrees. 0 degrees is right here. So here, think about how I get to this point. If my radius is 1, that means that this value right here is 1 unit. So to get to this point, I would have to go to the right 1 and up 0. Remember that these are just my x and my y, which are my cosine and my sine. So if I asked you for, say, cosine of 0 degrees or 0 pi, that would be 1. If I asked you for sine of 0 degrees or 0 pi, that would be 0. Let's take a look at 90 degrees. So here, I've got 90 degrees. So here I go 0, 1 to get to 90 degrees. So this would be my cosine, 0. Cosine of 90 would be 0. Sine of 90 would be 1. Same with 180. So 180, I've got negative 1, 0. So that means my cosine would be negative 1. My sine would be 0. And for 270, or 3 pi over 2, that means that I'm going 0, negative 1. So my cosine would be 0, and my sine would be negative 1. So all the unit circle is every single angle with a 30, 60, 45, or 90 degree reference angle, all put together into one circle with all the degrees, radians, sine, and cosine values. So it's a lot of information, but if you just think about it piece by piece, it makes it a little easier. So if you can just do what we just did with all of those angles, you're going to be fine. So you just need to be able to do cosine and sine of all of those angle and radian measurements, which seems overwhelming. But again, draw the angle, find a reference angle, know your special right triangle side lengths, and then think about, depending on what quadrant it's in, whether the x and y values are positive or negative, and you are good to go. So good luck. Don't forget to like and subscribe.